because it's 9 total. A series circuit, we can connect series circuit in multiple ways, in many ways. Let's start with the first method. So we could have two resistors in a circuit which are connected end to end. That is a series connection. So it's from the beginning, you have one component, connect next to the other component, to the other component, and back to the voltage source. Now I want to have a series circuit. Initially I had a simple circuit where I just have one resistor and a light bulb. Now, or LED, we are putting the second resistor. And you see already our power, or our LED is already lighting. But now we have two resistors. Series circuit, we have two resistors. Still the same principle. Voltage across the battery is equal to the sum of voltage drop across the first resistor, second resistor, and voltage drop across the LED. You take V1 plus V2 plus V3 is equal to V. So if this is 7 again, we should see what is the voltage drop in all these three components. So let's see. Again, positive, this is negative. 7.34 volts. That's the total voltage. That's the voltage across our voltage source, which is the battery, 7.34. The battery has 7.34 volts. So if we start with the first resistor, the voltage drop here is how much? 2.68 volts. 2.68, 2.65, 2.6 something. 2.6, 2.7. Yeah, so it plays there. 2.6, 2.7, 2.6, 2.7. Great. The second one, the second resistor, is 2.5 something. Almost the same range. Minor deviations. Basically, it might be also because of the strength of my connections here. Seem to be hanging sometimes. So let's go back again. 2.7, 2.6. 2.5 something, 2.6, almost 2.6, 2.7, 2.6, 2.6. Yeah, it goes there because this and this are the same value. There might be some slight differences here just because of these connections and so on, but it's more or less the same value, 2.7, 2.6, 2.7, 2.6, so almost same. If we come to this guy, we have 1.96 or 1.97. So 2.7, 2.7, 1.9, 2.7, 2.7, 1.9. We see here. Yep. If you sum these, 1.9 is almost 1.98 is almost 2. So 2, 2.5 or 2.6, 2.6. Yeah, already you have 7.3, almost 7.2 something, 7.3. Now remember initially when we had only one resistor, we measured current, and current was of the value of around 22, 23, around 23 milliamps. Now let's measure the current when we have two resistors in series. What happens? We put it on the current side, so 200 milliamps. And let me use this knob here or this switch, take it off. But when we connect back, you'll see the LED going on. Let's measure the current now. So remember polarity. If we reverse, it will read a negative value. You see, we have two resistors, the first resistor, the second resistor, and an LED. And what do we have? 11.5. Initially we had 23 point something or 24, 23 point something. Now we have 11.5, 11.6, almost half. So we double, the resistance is now doubled, the current is halved. So you double the resistance, you halve the current. When the resistance increases, because we have two resistors of 220, 220, so 400 and something, the current goes down. These are principles of a series circuit.